So in this video, I want to talk about trig functions. I want to talk about the idea that this y equals sine of x can be graphed. It's a function and it has solutions, just like linear functions, just like quadratic functions. It has inputs and outputs. So for every input, there's an output, which means it can be graphed on an xy plane. And the graph has a certain shape, just the way quadratics have parabola. And so I want to look at that. So the way we're going to do that is looking on a unit circle. We call it a unit circle because we'll call this radius of length 1 inch, or whatever we want to call it. And so we have these triangles as we go around, something like this. This is 1, length 1, and we drop this down at a right angle. And so if we were talking about, this is our angle here that we're talking about, this is our x, and we say the sine of x is the opposite over the hypotenuse. In this case, we're talking about 30-degree angle. So the sine of a 30-degree angle is 0.5, meaning that this is exactly half the length of this. And you can see that this is half of this. So the sine of 30 is 0.5. If we were to continue moving this around the circle, dropping this down at a 45, and then we took the sine of 45 degrees, the answer would be 0.707. And you can check these on your calculator. As we continue to move to 60 degrees, so these are our inputs, the angle is the input. So the sine of 60, which is the opposite over the adjacent, is 0.866 rather. So you can see that it's increasing, 0.5, 0.7, 0.8. And then you can also notice that this side is getting shorter and shorter over here. If I were to draw an angle like this side is decreasing and it's approaching 0, as this side is getting longer every time. It's getting longer each time, and eventually it's approaching 1. And when you get to the point where you're sort of straight up, you have the opposite and the adjacent will be on top of each other, and it'll be 1 over 1, so that you say that the sine of 90 is 1. So it increases. It starts at 0, and you can also see as this goes lower and lower, if I was to draw an angle here, this is decreasing to the point where it's 0. 0 over 1 will equal 0. So the sine of 0 is 0, and then it increases 0.5, 0.7, 0.8 until it gets to 1 whole. And then it continues on the opposite side. Same thing if you flip these over. So it's the same thing happening over and over again here. So now it starts to decrease, 0.8, 0.7, 0.5, and 0. So just quickly, this looks the same as, this is a 30-degree angle, essentially 150 degrees if you were to rotate all the way around. We call this a reference angle, 30 degrees, because it has the same ratio of 0.5. So you're increasing from 0 all the way to 1 whole, and then you're decreasing. And these are the angles, your input, and these are your outputs, because you're taking the sine of the angle. And then when you get into the negative, because you're dropping down, downward, this would have a negative measure. So it's the same ratio, only this is a negative, because if you were to plot this point, you would move in the negative direction and then downward. So you end up with a negative answer. So if you took the sine of 210, and you can check this on your calculator, you'll get negative 0.5, and then negative 0.7, and negative 0.8, and then negative 1. And then you start increasing again, just as you did before, well, decreasing in this case. No, increasing, I'm sorry. So 0.8, 0.7, 0.5, and then back to 1 again. So you're just going around a circle, and that will continue over and over again. So if you were to put that in table form, inputs and outputs, as I just explained it, this would be your x, and this would be sine of x, or your y value. And as I said, if I plug in 0, I get 0. If I plug in 30 degrees, I get 0.5. If I plug in 45 degrees, I get 0.707. Just as I explained it in the picture. 90 is 1. Then you start decreasing back down again until you get to 0, and then you get into the negative numbers. And so, of course, if you have inputs and outputs, you can graph that on a coordinate plane, which I have here for you, and you get the graph of y equals the sine of x. Can't fit this in the video. It's right here, y equals sine of x, because as I said, sine of 0 is 0. The sine of 90 is 1, and then as you increased up to 90, you got 0.5, 0.7, 0.8, 1, then back down 0.8, 0.7, 0.5, 0. Then we went into the negative, 0.5, 0.7, 0.8, negative 1, 0.8, 0.7, 0.5, 0. And now you're back at 360. You've gone a full rotation of the circle. So as you're moving around the circle, this is happening, and you're plotting the points. You're plotting the sine of everything. So, and then it continues, and this wave goes on and on forever. That's why we have arrows here. So as I said, the graph of a linear function is a straight line. The graph of a quadratic function is a parabola. You've seen other functions. You've seen the graph of the absolute value is a V shape. And so this is a sine function. You could do the same thing going around the circle with a cosine, and you'll get this graph here. They look pretty much the same, other than the sine of 0 is 0. The cosine of 0 is 1, so it starts up here. So that's how you can recognize a sine function versus a cosine function. The sine function cuts through the origin. The cosine function starts up here. Okay, and you know, you have your basic transformations. We call this amplitude. The height of the sine wave is 1, and that's represented by a 1 here. If there were 2 here, then you'd be multiplying all your answers by 2, and then the wave would be taller. So that's a transformation. You could add like a +6 at the end here, and the whole entire graph would shift up 6 units. It would keep the same basic shape. It would just be up higher. And so the same kind of transformations that you do to quadratics that you saw in Algebra 2, you can also do to trig functions. So I just wanted to make this video just to introduce the idea that sine and cosine and tangent as well are actual functions with inputs and outputs, and they can be graphed.